welcomes in our next session. In our today's lecture, we are going to solve very interesting results relative to powers of I. Now we know that one important result, we know that what the result we know? We know that I square is minus 1, right? In the case of complex number, I square is minus 1. Where I is what? I is any kind of imaginary number. Actually, I is square root of minus 1, right? This is an imaginary number. Okay, with help of this, we may define complex number very well, right? But now we have to discuss about powers of I. So, let us see what about powers of I. Powers of I. Okay, I is such kind of number which is the square root of minus 1. Obviously is an imaginary. Okay, now let us see what about I cube. So I cube, let me calculate. I cube can be written as I square into I. But as we know that I square is minus 1. So this is minus 1 into I. It means minus I. So I cube is minus I finally. What about I raised to 4? Let us see. Then that can be written as I square into I square. It means minus 1 into minus 1. So I raised to 4 is the real number. See, I raised to 4 because 1 is real number, my friend. So I raised to 4 is a real number. That after I raised to 5. Next, I raised to 5 again can be written as I raised to 4 into I now, because now we know that I raised to 4 is 1, so 1 into I, and I raised to 5 is I. Now I think you can say that what about I raised to 6 is I raised to 4 into I square. It means 1 into minus 1. See, I square is minus 1. So that's why I raised to 6 is minus 1. It means I raised to 6 is same as I square. This is our conclusion. What about I raised to 7? Now I can say that is I raised to 4 into I cube. And I raised to 4 is 1 now. So this is 1 into I cube. That means is same as I cube. And what is I cube? I cube is minus I. The first result, see. I cube is minus I. Now what about I raised to 8? I raised to 8 is I raised to 4 into I raised to 4. 1 into 1. 1 into 1 is 1 again. And so on. Now this kind of several powers of I we may derive easily. But my friend, what is our conclusion? Our conclusion is this. I raised to multiple of 4 power. It means I raised to 4. I raised to 8, that after I raised to 12, such kind of powers of I is 1. So that's why our conclusion, I just write the conclusion related to this all power. Conclusion. Our conclusion is this, I raised to 4n is 1, right? Where n is belongs to n. It means, why I write n is member of n? Put n equal to 1, you get I raised to 4 which is 1. Put I equals to 2, then I raised to 8 is 1 as we proved there. Similarly, I raised to 4 3s are 12 is also 1. It means I raised to 4n is 1. Now I raised to 4n minus 1. See here, I raised to 4n minus 1. So I cube is there. That after I raised to 7 is there, this kind of number, n equals to 1, then I cube is minus I raised to 7 is minus I. It means I raised to 4n minus I is minus I, where n is member of n. Now I raised to 4n minus 2. Let us see what happened. I raised to 4n minus 2 is I raised to, put here 1. Here what we have to do, put n is member of set n. So when we put 1, what we get? I raised to 4 minus 2 I square, and I square we know that is minus 1. That after put 2, I raised to 6 is again minus 1. So I raised to 4n minus 2 is minus 1. And at last I raised to 4n minus 3, that is equals to plus I. Just put 1, you get 4 ones of 1, 4 minus 3 is 1, where n is belongs to n. So this is our conclusion, and these are powers of I also. So just we have to remember this conclusion very well, right? So now imaginary number I is given, then any case we may define the power of I, right? And now let us learn about very interesting thing, that is the relevant result, or you just say that identities. We may write as identities. Let z1, now you know that z is a complex number. Let z1 equals to a plus ib, and z2 is equals to c plus id. This kind of complex number are there. Now you know that every complex number can be written as a plus ib or c plus id, whatever. So let z1 equals to a plus ib and z2 equals to c plus id are given complex number. Then what about addition and subtraction? We know that addition, how we add this to complex number, we know the addition. First we have to add only real part with real part plus I into imaginary part with imaginary part. So then simple algebra also applicable. It means which kind of simple algebra? As we know that x plus y whole square. Similarly here also we may write z1 plus z2 whole square can be written as z1 square plus 2z1 z2 and plus z2 square. It means simple algebra is there. Second one, z1 minus z2 whole square. z1 minus z2 whole square can be written as z1 square minus 2z1 z2 and plus z2 square. As you know that x minus y whole square, right, my friend? And third result is z1 minus z2 whole cube, suppose. Then z1 minus z2 whole cube. You know that what is the expand of x minus y whole cube? The similar expand is this, z1 cube minus 3z1 square z2, I think you know that, plus 3z1 z2 square and minus z2 cube, right? And the fourth one is a simple thing, z1 square minus z2 square, that is z1 minus z2 and z1 plus z2. And the fifth one, z1 plus z2 whole cube, I think this term is remain, addition and subtraction. So that is what here, z1 cube plus 3 z1 square z2 and plus 3 z1 z2 square and plus z2 cube. So these are identities, a very simple results relevant to it. Now let me divide two complex number. It means division of two complex number. How we divide? Then remember that in that case we have to apply solve. It means division of two complex number. Let us see. Division of two complex number. Division of two complex numbers. So now let z1 equals to a plus ib belongs to c. C means set of complex number, and z2 equals to c plus id belongs to c. If z2 is not equal to 0, then z1 upon z2 exists. Otherwise not. It is very obvious. Division exists in the case that denominator is not equal to 0. Now main thing is this, how we divide this two complex number. So z1 upon z2 can be written as a plus ib upon c plus id. But this can be done with this a plus ib upon c plus id. Now my dear friend, apply surd. You know that surd means multiply and divide with the conjugate related to denominator. denominator's conjugate, c plus id is in denominator, then try to removing the terms of imaginary. It means here imaginary numbers. Try to remove. How we remove this? Multiply and divide with its conjugate. तो आनो conjugate apply करिए. What is the conjugate of c plus id? You can say that c minus id is the conjugate, right? And then in the case of denominator, or in denominator, you easily remove this complex number. It means real number will be there. So with this process, you know that this process is solved. Solved means multiply and divide with its conjugate. With this process, what we say? With this process, denominator becomes real number, right? It means imaginary number reducing with the help of this solve, right? So we may divide any two complex number with help of this process. See here, for example, if you want to divide 6 plus 3i upon 2 minus I, see here, 2 minus I, then how can we divide it? 6 plus 3i upon 2 minus I, and multiply and divide with 2 plus I. See here, multiply and divide with 2 plus I. It means this is known as solved. Now what happened? Then numerator is 6 plus 3i into 2 plus I. See here, upon. What about this? It is very easy that as per the factorization, or as you know the factor of x minus y, x plus y, I think you know that is 2 square minus I square. 2 square minus I square. And now in numerator, this 6 multiply to this both terms, 6 2s are 12 plus 6i plus again 3 2s are 6i and plus 3i square upon. This is 4 minus 1. Remember that I square is minus 1. I square is minus 1. What is this? This is now 12 plus 12i. See here. And plus 3 into minus 1, my friend. Upon 4 plus 1 means 5. Right? I just write here the reason is I square equals to minus 1 in both cases. I square is minus 1. Here also this I square is minus 1. 6i plus 6i is 12i. Now what about numerator? I think you easily say that 12 minus 3 is 9 plus 12i upon 5. And finally this is your division. But actually we may write it as the form of a plus ib, 9 by 5, it means 5 I write separately plus I into 12 by 5. See here, I just write 5 separately, 9 by 5 plus I into 12 by 5, which is of the form a plus ib, my friend, which is of the form a plus ib. Remember that. And this form is known as the general form of a complex number. This is general form of a complex number, my friend. Remember that. So every complex number can be expressed with help of this general form, which is also known as general form of a complex number. I think you know that here real part of z, say as z as a complex number. And now you know one more thing, this is real part and this is imaginary part. So here real part of z is what? 9 by 5. See, this is real part of them. And imaginary part of this complex number is 12 by 5. So real part and imaginary part plays very important role. So I think now, my dear friends, you easily find out it. Okay. So here we stop now. Here the lecture is also going to be end. But in the next lecture, now we will deal with the next exercise. It means we will start exercise 5.1 in the next lecture. Thank you very much.